Hello everybody, welcome to Physical Science. Today we're just going to take a few notes here before we start our lab. Okay, so if you notice our notes, we're talking about changes, we're talking about physical and chemical changes. The hard thing is they both really have a lot of commonalities. So we can start by size, okay? So if we have a change in size of something, what would you consider that, physical or chemical? Okay, physical is what you all said, right?
Yeah.
I would say that is definitely true. Size would be a physical change. Like if I take a hammer and I hit it and it breaks into many pieces, then it changes size. Does that make sense?
Mr. Wong?
But if you think about a chemical change, then you can actually have a size difference. If you're changing it into a completely different chemical, then there's going to be a size change there too. Do you agree? But typically when we talk about size, we talk about hitting something with a hammer basically, or mortar and pestle making it a lot smaller. How about another thing? How about color? What if we see a change in color? Okay, so half the room said color is physical, and I do agree with that. A color change can be physical. Think about it. If you put yellow and green together, do you get a different color?
Yeah.
Yes. Does that mean that those paints that you put together have been chemically changed?
No.
No, it does not. So a color change can be a physical change. But most commonly, we would think of a color changing happening with a chemical change. So those of you that said color for chemical, you're right too. In fact, you might be a little more right saying chemical, just like size was maybe a little more right saying physical. The confusing part is these things can actually go for either one. So then we have to figure out which is which. So if we have a color change, like in a test tube, then most commonly we will be seeing a different chemical being formed. Now, there's another way that a color change can happen as physical. Like let's say that you put a little grain of something into water and it dissolves. Do you remember what dissolves means? Well, yeah, dissolving means that something is breaking down into small enough particles that it can be held in solution, which is a homogeneous mixture, right? Held in solution, but you can't see, you can't tell it's there because the particles are so small. For instance, salt water is a dissolving, it's something that has been dissolved. Now, if you get a colorful, something that looks black, and you put it in water, and the water turns purple, it could just be that when this dissolved, that the particles are so small you can't actually see the particles, but you can see their actual color. So you can have a color change in a physical way too. And in fact, you're going to see both of these today in lab. Now, how about bubbles? If you see bubbles, is that physical or chemical? Okay, so people said mostly chemical, and I would have to agree with that. That is probably, I was going to put chemical, it should be bubbles. That is probably one of the biggest telltale signs that there's a chemical change. And when you see the bubble, what does that mean that it's formed? A gas, right? Some kind of gas, okay? So, the solid liquids, gases, plasmas, a gas is usually formed as a byproduct or product of a chemical reaction. So bubbles usually mean chemical change, but they can also mean physical change. So when would seeing a bubble be a physical change? Any ideas? Well, have you ever opened up a pop? Have you opened up a pop bottle and you see a bunch of bubbles all of a sudden in the pop? Do you think that was a chemical change? No, that was not a chemical change. What happened is that carbon dioxide was dissolved into the liquid. And the reason why it was dissolved, if you ever shake up a bottle that hasn't been opened yet, it gets really hard, right? You can feel that pressure. That pressure pushes on the surface of the liquid, and then that pressure it pushes throughout the whole entire liquid. And so that actually is pushing the gas and dissolving the gas into liquid. Did you know that gas can be dissolved in a liquid? No, know, you always think about like solids being dissolved in a liquid, right? Well, gases can too. So when you open a pop bottle, it releases the pressure, and that pressure that's holding that carbon dioxide in the solution then releases, and then all these bubbles appear. That is not a chemical change, that is a physical change. So hopefully this cleared things up a little bit for you, or maybe it made it more muddier. But regardless, at least it should make you understand that you can see a lot of these changes in either a chemical or physical change. So you have to think even further than just looking, hey, bubbles is a chemical change. It could be physical. Or hey, color, it's a chemical change. It could be physical too. And that's what you're here for, thinking, right? One more thing on the lab today. If you look at the label and it says strong oxidizer, that's going to be something that can burn you if it gets on your skin. So be very careful. We are using a strong oxidizer in lab. A very little amount, which, you know, it wouldn't kill you or anything, but you could get a little bit of a skin burn, so be careful with that. Any questions? Okay, one more change. How about temperature? What would you say, chemical or physical? Okay, both. You're getting pretty good at this. So temperature could be both. Now, if you shine the sun onto something, does it change temperature? Yeah, that's a physical change, right? So that's how it could be physical. Typically, we think of temperature as what happens in the test tube without any like outside influences. So if I put two chemicals together in the test tube without any other outside influences, and there's a temperature change, which means it either gets hotter or colder, then that is a clear or more clear indication of a chemical change. Okay? And also on bubbles too with that, you know, if there's no pressure change, which is a physical change, then that would be a better indicator of a chemical change too. And then color is, you know, usually an indicator of new chemicals that have a whole new set of characteristics. But, you know, you could screw up on that too, because like you put two colors together in paint and you get a different color too. So I want you to be more aware of these things than just saying, well, it's always going to be physical or always going to be chemical. Okay, hopefully that helps clear things up a little bit for reals. Okay, and I guess one last change that I didn't talk about here, which is something you will see in lab today, is what we call, and this is going to be on the chemical side, so we're going to call this a precipitate. Well, that's what it is called. And it is PPT is the abbreviation for that. And the definition of a precipitate is an insoluble solid. And so what happens then, you put two chemicals together, so let's say this is your beaker, and you put two chemicals in, and what happens is they combine, and then they make these chunks, or these little particles, insoluble solids. And it's usually like a suspension, and if you let it sit around for a while, it'll kind of all bunch up down here at the bottom. So I remember precipitate, because precipitation, water falls out of the clouds. A precipitate or insoluble solid falls out of solution. And that is always indicating a chemical change. Okay, hopefully this helps.